checked us in yesterday for dinner. But I know what's a good price and what isn't a good price. So if we're at a relatively high price, so this is a relatively high price for this product, not for it. So it's not an absolute value. It's on a product by product basis. So if you're drinking a $10 bottle of wine, if it's $12, then you know that's a high price. That's a high price for that product. If it's $8, you know it's a good price. So yeah, that's a good price. I know on average it's around $10. $12 is high for that price. But if it's a nice Alexander Valley Cab, then it's a $20 bottle of wine. I can find it for $17, $18. That's a good deal. $25, I probably wouldn't buy it. But at a high price, we can see that our total lift, including price and promotion, is going to be relatively small. Why? Because we're not really changing behavior much. Prices are high, people aren't buying much to begin with, and the promotion, taking $1 off a product that's already, $5 too high is not much of a deal. And we know that. Especially with products that we buy on a repeated basis. Again, if you're buying something that you can usually get for $15, for $18 is too high, $17 is probably too high, and so promotion's not going to have much of an effect. Small promotion will. If we're at a low price though, then we get a big promotional lift. So, at a high price, any kind of promotion, again, this is assuming I'm familiar with the product, any kind of promotion is just going to draw attention to the fact that the price is kind of high. If that's at a low price and you promote it, you're drawing attention to the fact that it's a low price. You should buy this one. So the answer is yes. The reason why this is important is because if there's heterogeneity, in other words, if people that buy on promotion are different than people that buy off promotion, then promotion is going to have different effects at different prices. And if that's true, then we can optimize the price promotion lift. Because with this, in this case, there is no optimization going on because promotion has the same lift everywhere. Right? These are parallel, so that that horizontal distance is always going to be the same. But here, that horizontal distance is going to be different, and which means promotional lift is going to be different at different points. All right. So we're still going to engage in the same kind of decomposition though. So here's the high non-promoted price. Here's the high promoted price, the lower but still high promoted price. And we're still going to get a lift due to price and a lift due to promotion. So the decomposition is the same, it's just the process of the decomposition is the same. It's just that we're going to get different results depending on where we evaluate the prices. And then at the low price, again, here's a relatively low price, non-promoted. Here's a lower price, promoted, and we get a relatively large promotional lift here. So those are the two main contributions of this paper. One is a methodology for measuring the effects of promotion by extracting or decomposing the price effect and the promotion effect. And the other is I think, putting to rest, at least in this specific industry, in the wine industry, the debate over whether or not these two demand curves are parallel and whether or not they're not parallel. So again, in the paper we can pretty clearly see the scatter diagram. Those are not parallel lines. You can see that this is flatter and this is steep. Remember, we're switching the axes when we do this in the scatter diagram. So we're putting price here and quantity there. and the regression's up. The regression is, we saw this to begin with. We can see that promoted demand is much more price sensitive than non-promoted demand. So little old ladies that will clip coupons and buy stuff on promotion, and will buy stuff only when it's on promotion. So this was how we ended 580. I think this was just a fabulous paper, if I do say so myself. All right, so we see those coefficients are different. We know there's a big price differential. So here's that first decomposition, and we evaluated it at a non-promoted price of $9, and I took it down $1 for a promoted price of $8, and we got that true effective promotion of 8.32% versus the total effect, which is 53%. So we're not getting a 53% return on our promotion, we're getting an 8% return on our promotion. Then I said, okay, well, we know the demand are different, so let's evaluate this a notch lower. And I didn't go much lower. I just looked at, instead of 9 and 8, I looked at 8 and 7. And for 8 and 7, the total lift was again bigger at 60%. But now roughly half of that is due to the change in price, and the other half is due to the effective promotion. So, yeah, the promotional lift did what we expected it to do. Promotional lift is bigger at lower prices. So you get a bigger bang for your buck at a lower price than at a higher price. Which again, it's almost one of those duh things. If price is relatively high for that specific product, a promotion is only going to draw attention to the fact that it's a relatively high price. It's, or if you buy clothes and you go into the Gap and everything says sale, but you look at it and it's the same price that it was yesterday. It's the same sweater, the same price that it was yesterday, except now it has a sign that says sale. Well, it's not on sale. Or if they do mark it down, what do they do first? Mark it up, exactly. They jack it up to $50 and then they bring it back down to 25% off, and you get a nice discount. So, but if you're familiar with that sweater, then you know that, well, I could have bought that yesterday for that same price. All they did is mark it up and then bring it down. And that's essentially what we're saying here. Promotion in those cases are going to have very small effects. If it's a true price reduction, and it's a good price, then the promotion is going to draw attention to the fact that we have relatively informed consumers, and they're going to know that this is a good price because it's a reference, because they're going to have that reference price. That sweater was never worth $50. No one was ever going to pay $50 for that, and hence now we have a lower price, and the promotion now draws attention to the fact that it's a lower price, and we get a bigger bang for our buck. So what we can really do now is, in the marketing literature, or in the job literature, really when you're looking for a job, you often see these marketing mix models. Marketing mix just means you have a mix of marketing tools. Price is one of them, and promotion is another one. Now we know that those two can work together to optimize kind of your promotional lift. And it's a pretty powerful tool. And you'll see this in the job. Familiar with the term marketing mix modeling? That's exactly what we're talking about here. We're modeling the marketing mix to optimize it. So, all right. Any questions? So we're going to do this, and then I guess to give you a peek to the future. We're going to do this with the binary logic, the binary stuff that we started talking about today. So, but let's start here first. This is literally where we ended. This is literally where we ended 580. And I think I made that last one optional, right? So probably you guys didn't even do it. Yeah.
I did.
You might have done it.
Should have.
Yeah.
Yeah.
So And if I remember correctly, I think we were probably drinking on that last class. too.
Might have been.
Could have been.
That was why I didn't do it.
Oh, yeah, that's right. That's
So,
what it was.
but it's a brilliant paper. All right, so let's do it. It's actually not that hard. So the key to this decomposition, and again, the key to this decomposition is, and we'll just use the simple picture because we know the process is the same. So I'm going to refer to this often. The key to it is this picture. So when we measure promotional lift, we have to evaluate it at, because the lines aren't parallel, we have to evaluate it at a specific price. So this will be a true point in the data. This will be a true point in the data. We need to once we find this hypothesized point, the point that says, what if I had just lowered price and not engaged in promotion? What would have happened then? And once we do that, we're able to extract out the effect of that lift that's due to simply the price reduction. So the key in all of this is to recognize that. All right. This is a, these are the nonlinear demand curves for our binary models.
Looks like decay.
Was that?
Looks like a decay.
Yeah, a little bit. So this is what we're working up to. Very cool stuff. And Tableau just came out with a new version a couple of weeks ago. Last one, so it would be yep, measuring the effects of promotion. All right, this is, again, the same data. Yeah, it's weekly data. It is not Behringer. It was, so the idea came from Treasury, and the stuff I did for them was for their Behringer Founders Estate. What I used in the paper, which I call anonymous cab, was Robert Mondavi Private Select. He needed some high volume, so he captured lots of data. I didn't do Chardonnay. Let's see, is my date stuff all fixed up? What am I doing? So we're going to generate. Yeah, week is the first one. Where did it go? There it is. All right. This is week ending data. We've used 4-week ending data. This is week ending data. Week ending data will give us a more accurate picture of promotion because promotions usually last 7 days. Sometimes longer, but usually promotions are 7 days. So we want to extract out the date so we can have a date variable. If you remember, we kind of use that substring thing to kind of cut out all these words. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. If we cut off 12 spaces in, then we'll have just the date. And that's what this is. So generate date 2. It's a substring of week. This is the variable week. And I'm going to start it at the 13th spot, which is here, and then go for however long it goes. So if this was 2005, that would have worked also. So if I tab date 2, it'll just be the date part of my string. Tab 2. That's what we got. We can convert this into a date variable by telling Stata to generate a date. And if we tab date, we'll get that, which is the number of, so this is weeks, it's weekly data, so this is the number of weeks since January 1st, 1960. So whatever this date is, it's 17,571 weeks after January 1st, 1960. That's how Stata keeps its dates. We just need to tell Stata, look, this is the date, stop giving us this number. We're not some sort of Rayman that wants to know. So we're going to format it, TD. And we can see now that here I just listed date and the variable week. Remember, the variable week was the big long string that we cut off in the first place. So just make sure they all match up. So April 23rd, 4/23/05, everything's good. We're good to go. Now we can construct any time dummies or monthly dummies or any of that stuff that we need to do. Here, do it. All right, that's pretty easy. Let's see. So I'm just summarizing cases, promoted cases and non-promoted cases. What we have there. And on average, we sell 1,400 cases per week off promotion. On promotion, we almost double that to 2,300 cases. Not almost double, but we increase that by less than 1,000 cases. And again, this is per week. So that's pretty good. That's pretty good. Now there's going to be some seasonality in that, so we definitely want to, we can definitely account for that. It's already fun. It's going to be even more fun. So what, I assume what we're going to do is reshape this data set from what's called wide format to long format. And this is pretty common when we do analytics. Yeah, that's exactly what we do. So, what does that mean? It means
Projector's good for something.
yeah. 1940s technology. So essentially what we have is something along the lines of, we have a variable for cases, promo, cases, non-promo. And let's say we got 1, 2, 3 observations. We got numbers here, numbers there. We got X, 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 Y, Y, Y. This is called wide format because our variables are wide. Essentially what we want to do, so right now we really couldn't even run a regression. We couldn't run this regression, for example. We couldn't run cases equals beta 0 plus beta 1 promo. We couldn't do that. What we need to do to run that regression is take the data and really, instead of having 3 observations, we need to take this data over here and add these y's here. So we're going to add 4, 5, 6, and this will be y, y, y. So we're going to take this data, kind of put them here, and instead of having cases promo and cases non-promo, we're just going to have one variable called cases, and then we're going to have a dummy called promo, and this will be 0, 0, 0, 1, 1, 1. So now we have cases and we have a dummy, we can run that regression and get the wrong measure of promotion. But it also means we can run it and get the right measure of promotion. So this is what we need to do. This is how the data comes from Nielsen. This is what we need to do the decomposition, to correctly evaluate the effects of promotion. Does that make sense? You can do this in Excel, kind of a transpose and that kind of stuff, but Stata is really set up to do this pretty easily. And it's called reshape, which is essentially what we're doing. We're reshaping this from wide format to what's called long format. Reshape is super powerful. I use it all the time. It's just a great, great tool because data doesn't normally come kind of out of the box ready to be analyzed. So we're going to use the reshape command. All right, so reshape. I'm going to generate this variable observations, which is just a number. And the command for reshape is reshape. Reshape what? Reshape long. Remember we had a bunch of variables called cases promoted, cases non-promoted, cases feature, cases, yeah, you can see that, cases display, cases feature and display, cases temporary price reduction. We had all those different variables that accounted for cases sold under those promotional aspects. For each of those, let's go up here since we got it. Yeah, these are all variables. So we had cases for non-promoted, cases for promoted, cases for feature, cases for display, cases for features and display, cases for temporary price reduction, average price, price non-promo, price promo. So we have all those things. We don't want all those. We want one cases, one price, and then we'll have a dummy telling us whether it's on promotion or not promotion. So instead of all those variables, we're going to boil that down to cases, prices, and that's it. So instead of, how many variables is that? Instead of 22 variables, we should have a handful, 2 or 3, right? We should have probably week, and then cases and price, and promo. So maybe 3 or 4, which is what we just did. So you just got to get used to the syntax. And the syntax is, believe me, I fumble with this as much as the next guy, which is why I put things in do file. So I'm taking a wide format and I'm reshaping it to long. And these are called the stubs. Stubs or nubs, I'm not sure which one it is. But these are the things I'm pulling. I'm going to pull price from all of these price display, price features. I'm going to pull price, and I'm going to pull cases from all these cases display, cases feature. So those are the nubs. So it's going to cut off anything that comes after cases, and it's going to cut off anything that comes after price. So that's what that means. And also for ACV, although we don't need ACV. I want to do it for every observation. And then I want to construct a new variable called promo. And that's what this is here. So this is going to be promo, and it's going to tell me what type of promotional activity is going on for each one of these cases and prices. So notice what we did. We had, we started out with 312 observations, which were wide, and 27 variables, which is real wide. But because we kind of cut them all up and attached them to each other, now we have 1,872 observations, but only 14 variables. And we can see that here. So we got observations, and now promo will tell us what's going on with each of these, whoops, with each of these observations. It'll tell us whether it's on display, whether it's feature and display, whether it's featured, whether it's non-promoted, whether it's promoted, and whether there's a temporary price reduction, which is TPR. And it does it instantaneously. Again, I'm sure Excel can do this, but Stata is literally set up to put your data in analytics-ready format. So perhaps the single most valuable command is this reshape command. I think I've mentioned this before. When I've talked to people out in the industry that hire you guys, the one criticism I get, you guys are smart, sharp, blah, blah, blah. The one criticism is, unless the data is set up for you to go, you don't know what to do. So this is a perfect example of the data is not ready to go. It's literally in the wrong format. It's got to be reshaped, and this reshape command, I can tell you, is just a godsend. You will use it frequently. Like I said, Nielsen data comes the way we saw it. That's how it comes. This is after I've already reshaped it. So, and most of the time you're not going to get data in an analytics-ready format. You're going to get it in an Excel spreadsheet, you're going to put it in Stata, and then that's probably where you should do your manipulations. But for most of the stuff that we're going to do, we're often going to want stuff in a long format. So if you find yourself fumbling with a data set that you can't do anything with, that's probably the reason why. It's in the wrong format. It's not set up to do any kind of really sophisticated analytics. Other than it's really set up to do Excel stuff. And you don't do a whole lot of dummy variables and regressions in Excel. All right, we're good to go. I can't tell you how many times I've heard reshape is my favorite command. Next to, I hate reshape. All right, so what did did I do? I just did a table of mean cases, and we get those same results, which is good. So it's good to get the same results. On promotion, off promotion, we sell about 1,400 cases per week. On promotion, we sell about 2,300 cases per week. That's what we would normally call that lift. But we know that a promotional lift is confounding or confusing the effects of price with promotion. So I'm going to construct a dummy variable for promoted and non-promoted volume. So, pretty simple. D-promo. Promo is already used, by the way. That's why I have to put D-promo. And promo is a string. It's literally the word promotion, non-promotion, feature, and all those things. So I'm creating a dummy that says 1 if I'm on promotion, 0 if I'm not on promotion, non-promo. All right. And I'm going to label it because it looks better when it's labeled. Oops. Bless you. So here's the table. Same table, promoted, non-promoted, promoted volume. All right. So let's run this regression, which we know is wrong, by the way. Promotion is positive. The coefficient on promotion is positive and significant. So it looks like the lift is about 921 cases per week. So we're selling an extra 921 cases per week when we go on promotion. That sounds pretty good. We can get a percentage out of that. How could we get a percentage out of that? A couple ways. But what's one way to get a quick percentage out of that? Those things that catch on fire. Logs. We put it in a fire, right? Good fires. Fires when I sit around a log. Not the bad ones where you're watching your house burn down. Yeah, it is a bad choice.
It's too soon.
Yeah. It's too soon. It's way too soon. It's way too soon. So let's generate ln cases equal natural log of cases. Oops. And we can get a quick percentage.